Over more.
Fantastic.
That's why you need to put stuff in
That's
clusters.
a feature. Okay, that's a feature.
It's to teach you that DR is important.
Ooh, will there be a test?
Yes.
Can I bribe my way to success?
It'll be multiple choice, so you'll be fine. You're used to Windows tests.
Never score less than 20%.
Well, if
Which
I'm
prison is the passport for an MCC these days.
Are you just going to video record this?
Yeah.
Are you actually going to listen?
Yeah.
That's what I better ask. I'm going to kick one of you guys off. Mo, you've been idle for 17 minutes. Sean, you've been idle for 2.5 hours. Who should I kick off?
I don't need
You can kick me off because I don't actually need to.
Of course, if you just had a Windows desktop, you wouldn't have to do this at all.
Okay, I'll kick Mo off.
See, you would never be kicked off if you had a Windows desktop.
Right, so I did install a Windows 8 VM yesterday.
Did it make you feel dirty?
Well, I got an email saying that this computer just connected to your account.
Did you guys take time to look at the update I sent on the meeting today with all the network headings and stuff, with all the headings of stuff we're going to learn about?
I did.
I did see that you put a lot of those things in there.
Excellent. You didn't actually read any.
No.
Mo did, because Mo cares.
I do care. I care very much.
Remember, we're being recorded. Is it audio as well? Oh, shit.
That's what I can edit it.
Okay. Okay, so we're going to log in to VMware. So you guys, the center, and what we need to do is use our Active Directory admin logins into what? Open that.
A slash prefix also works.
Slash prefix does also work. I just find that easier to type. So you have to.
Yeah, that's because you didn't. Oh, you might have put your teeth in NT4 and whatnot. In that case, it's native. So use the slash.
I do.
This is all very modern. The UPN.
I would use the slash, but whenever you use this, just open bet in capitals and put slash, it doesn't seem to work. So if you use
open it.
yeah. So by the time you typed all that and then hit slash, you might as well write it like that because you're used to writing email addresses these days. Anyway, let's hope this still works. Because I changed my password earlier. Boom.
Yeah, they go away.
No. Welcome to VMWare.
There's the background.
I'll add it later.
We didn't need to put this on the server, did we? This could have been a workstation.
Okay, so you've all seen this console before. You've all had some exposure to it. So let's just jump in. You should know the home screen. It kind of gives you the breakdown of all the various different parts of VMware. The bit where we're mainly going to use in day-to-day is hosts and clusters. We've obviously got 4 data centers: Athens, Chiswick, VR, Romania. I'll just focus on Chiswick for now. Okay, first of all, I'm going to be discussing networking with you, so how the hosts are connected and all the rest of that. So let's jump in. There's slight differences between the clusters, but let's go and have a look. So I'm selecting a server within a cluster. This is VMO5. Then we go into the configuration tab, and we're going to be looking at network adapters. Okay. So this server has got 6 network adapters shown. It's actually a blade, so it's got 2 10 gig adapters, which are carved up into 4 smaller chunks. What we actually have is the 2 data network adapters are running at 4 gig each, so we've got 8 gig of bandwidth going out. The storage adapters, these 2 are running at 6 gig each. Let's stick with the network for now. We're not using these here. They do show up in some monitoring programs as being down and warnings pop up, but yeah, just be aware that we should only be using the first 2 NICs for the time being. Storage adapters, we have our own IQNs now. We have our own system.
What's
So
an IQN actually?
actually, I don't know what it stands for. I used to. Internet qualified name. Internet qualified name, maybe. Yeah,
It's
you could
even
do
the
that.
ice does even
Yeah.
identify.
It's also referred to as a WWN. Qualified name.
So those NICs are essentially just
Actually, in
a
fact,
COS
there's WWN.
device, really, aren't they?
Sorry?
The NICs are essentially just a COS device. They're just virtual allocations of the existing bandwidth.
Yeah, but it was presented as actual separate network adapters to the actual
Yeah,
physical
it's a
host.
hard OT service.
Yeah, basically. Yeah, I believe you can actually set it to float as well and actually dynamically scale bandwidth in different areas, but we haven't done that. We've fixed it. Hardcore fix. So yeah, we've got our IQNs set through, as you can see. Format is, well, IQN, year and month of registration of the following domain, com.openwest, obviously in reverse, openwest.com, and then the host within that domain, which we're sort of individually tagging. And then the reason why we have a decent naming system of our servers, so we don't get conflicts.
Facilities.
Okay, so networking. This is a standard sort of network configuration. As you can see, there's no network adapters configured for this. This was used for purely a migration task. I've left it in because we can use it to migrate between the virtual distributed switches if we wish in the future.
What that particular part, the NFs.
Yeah, so basically this is a single switch with lots of VLANs which exist on top of the switch. Yeah,
What is
uplinks
that?
first. So let's look at the uplinks first because that's what I've got listed. So we've got 2 uplinks. This is a distributed switch. Okay, vSphere distributed switch, DB switch -IT. As you can see in here, we have 2 NICs. And if I go to manage physical adapters, we can actually have a look. We can go to add and we can add in other ones. But obviously we don't want to because we've set them up to.
What does it mean by distributed switch actually?
It means they're shared across more than one host.
Hosts and clusters.
Physical hardware.
There's no physical hardware, it's a virtual switch.
Like they said, over different chassis or whatever.
Yeah,
Yes.
so it just means you can configure it once and then you can share it across all of them.
So if I add in another host, it instantly has access to all the networks on this
You
distributed
have
switch.
to do it that way because otherwise vMotion won't work because you couldn't guarantee that you have the same configuration on the chassis or whatever you're moving it over to.
Well, you can, as long as you have really decent control over what the networks are, which is fine if you've got like 2 hosts, which we'll look at later in the DMZ. But because we're going to be scaling up internally quite rapidly, and we've got quite a few VLANs now, it just
I
means
don't think vMotion would let you do it if it wasn't.
yeah, but you need to have a destination switch with the same name. So if you make a typo, it doesn't work. Yeah, if you change a capitalization or decide you want to call it internal rather than int, it doesn't work. So sort of control over all this is quite good. The distributed switch is good because you don't have to worry about all that.
I think there's difference between a local policy and a domain policy for GPOs.
So those are basically the uplinks. Now they're trunk connections going up into the blade chassis, and that is when we'll deal with the blade chassis on a different session. Inside here, you can see we have the names of the networks, backbone, and it's got a VLAN ID, backup with a VLAN ID, and so on and so forth. Now, what I'm going to do now is change this into the networking view. We go to Chiswick, we go to the distributed switch down here, switch. So these are the networks we have. These are the VLANs which are on them. These are the number of VMs on each of the VLANs. These are the number of ports. Now, the number of ports is quite important. basically the distributed switch, and any switch within VMware has a set number of ports. And you can't put more VMs onto that switch than the number of ports you have. So I've set
Is
all.
that per VM or per interface?
This is connections into the switch. So if the switch has got 512 ports, if you've got 513 VMs with one NIC in each of them connecting into it, then that's over your limit. If you have 128 VMs with 4 NICs going into the same network on each, that hits your limit as well. So it's the number of individual connections.
Is each VLAN on a separate switch?
No, there's one big distributed switch.
Okay. And these ports I noticed when you clone let's say for example the host, then if you go and change the network label, it initially takes the same.
We'll be looking at the VM detail later on.
Okay.
So that's down in the standard section, a bit further down. These are all the VLANs. The big thing really is the VMKs.
That's what? Why pick 512, or is this limitation?
No, you can go as high or as low as you want, pretty much. I picked 512 simply because I felt that 256, obviously the limit of the number of IPv4 addresses you can get on a /24. But as we're starting to look at IPv6, we should actually have a little bit of headroom. I can't imagine we're ever going to have more than 512.
Can you change that?
Yes, you can. So if I wanted to now, I can go into here, settings, and change number of ports. There are various binding types. I've set it to static binding. It's what we're going to use it for. Absolutely fine. There are lots of other ways you can do it, but there's pros and cons to it all, and this is fine for us. VMKs, right. If we go back to hosts and clusters, you will see further down in here we have VM kernel ports, ergo VMKs. Open that up, does it let me? No, it doesn't look like it's going to let me. There we go. So each host runs 3 main VMKs. I'll show you that with the virtual adapters. VMK0, VMK1, VMK2. VMK0 is the server management VMK, so it's in the 64 VLAN, and obviously the IPv6 further down. And this is for managing the VMware host. Okay. We've then got VMK1, which is the live migrate virtual kernel. So this allows the VMware host to talk to each other to do vMotion. And you'll see this is on VLAN 61. And then we've got VMK2, which is the NFS connection from the host to the SAN network. And you will see that's on VLAN 55.
Okay, what functionality does these VMKs give you? Obviously what you just
0
said.
is for management, 1 is for
but
vMotion.
why do you have this separate to the VLANs? Why?
This is for the actual VMware host to talk out on. So the VLANs allows you to present it to VMs within the host. The VMKs allows the host to talk on those VLANs.
Stands for virtual machine kernel, right?
VM kernel, yeah.
So it's responsive to the system to the system pushing down to the OS.
It's the ESX host. Yeah. So the underlying physical host. They obviously need connections into the network.
Each host has has those three.
So nothing to do with the VMs themselves. The VMs
This is just the underlying host OS, what VLANs it represents.
exactly. Exactamundo. And VM networking. So VMs themselves. I don't think anything's on 5 currently. Let's jump across. And yeah. So as you can see, On VLAN 63 we have 4 VMs currently. One of them looks like it's turned off, or it's not connected, I should say. Let's just have a quick look at that. There we go. Edit. So it's got multiple connections, and 2 of them are not connected. So the only connection currently from this host is into server management, which is why this port here shows us live not green. Right, that's the networking section of the host. Let's look at storage. Now, storage. Actually, no. Let's do the DMZ one first. DMZ networking. So the DMZ networking doesn't use distributed switches because you require either a special license or Enterprise Plus to be able to use distributed switches. So in here we have a standard V switch with these manually named VLANs. Okay, these are created the same on both the hosts, and if their naming is misspelt, it won't work properly.
Can you script that?
Yes, I believe you can, though I didn't do that because I was only creating 2. Anyway, the VMKs here, as you can see, are slightly different. Instead of being called VMK 1, 2, 3, 4 and whatnot, we've actually got SAN, NFS, DMZ, VMK, and so on and so forth. Management network, live migrate. Yeah. Now,
where do you assign hosts to be on the vSphere distributed switch or the standard switch? Or is it just a case of policy they're automatically on the distributed switch unless you...
I'll show you that in a second when we get down to the VM stuff. Okay, so the DMZ hosts have got a pair of connections which serve the main data the main data switch, and then we have 2 individual virtual switches with a single connection each. And this is for storage. And the big difference here is the storage is terminated with software initiators in the DMZ compared to hardware initiators in the blade chassis. So this will put more load on the CPU and probably be slightly more latent. So yeah, as you can see, VLAN 53, VLAN 54, side A, side B. Other than that, the VLANs are dealt with in the same way. The only difference is the uplink slightly, but yeah.
Why are they on different subnets?
The iSCSI ones, so that you don't get routing mix-ups. It's best practice with VMC. Okay, so actually, no, I'll continue on with this switch. So storage adapters here, these are terminated with the hardware, and we haven't actually created a software initiator on this host at all. So if we jump back to here, you'll see if I go up, the iSCSI software adapter. Right, moving into storage. iSCSI offloading. So here is where the offloading happens on the blade ones, which is the hardware adapters. This is configured through the blade chassis, and each time it boots it recollects its information from there, so you can't just make a change here and expect it to work, because it will go away quite rapidly. Here, as you can see, it's discovered, it's put the correct target, it's established a connection, and we'll be covering the other side of this when we do the SAN course. And as you can see here, it's got 3 disks presented to it. We have 10 gig and 2 terabyte disks. Okay. These are labelled in the storage section, which we will come to soon actually. So yeah, this is basically dealt with in the blade chassis, but you need to know that this is what does the offloading. In the DMZ, we use the software here to offload. Let me just go in. Now, here's the difference. When you're using the software offloads, you have to basically associate it with VM kernels. So you have to go in and add the VM kernel, which is associated with adapters and so on and so forth. And we then have both the routes to the SAN set up here, and then it's obviously established connection to the SAN and get your LUNs. Back down here, LUNs and naming, storage. So we have some LUNs here presented, 2 terabyte LUNs. This is obviously the naming scheme, int for internal, ESX, presented through ESX, it's part of the IT cluster, and it's the first LUN in the IT cluster. The last bit here is just to let you know what block pool it is a part of. And we'll cover this more when we hit the SAN, but each block pool in effect is a different RAID. So if you want to guarantee that the VMs you're putting in are on different physical RAIDs for redundancy, you need to go in and have a look here about what's going on. Yeah, this will actually come into another area about DRS a little bit later, so we'll come back and cover this a bit more. VM storage. So inside here, you okay, Sean?
We'll see when the eggs come in.
Okay. The VMs are all stored in folders, so please, when you create the VMs, create it following the naming scheme, or have it as a temporary one which you can delete. Don't put FQDNs in, because that will just annoy people and make the folder names ridiculously long. Going into the data store, the name of the VMs are also in these files here, as you can see. Let's just range this by size. So we have the main VMDK. This particular one doesn't seem to have any snapshots. The VMX here, if you want to import a machine to VMware, which has been removed, but you still have the storage, or you restore a backup, you've got to go into here, right click and go to add to inventory. You can't do it if it's already in and obviously turned on. So that's quite a useful thing.
Where you go inside the folder itself?
Inside the folder to the VMX file, and you go to add to inventory. Within the VMs themselves, let's have a look at Kepler. We've got 2 hard disks here. This is where they're stored. So this is on the second IT pool called block on the RAID block pool 3 in the folder Kepler VMDK. This one here has got Kepler_1.vmdk. Okay, so when you have multiple drives, it just does _1, 2, 3. I don't know what happens when you get over 9, because I've never done it, but I guess it rolls up to 10. So that is the storage of the VMs. Okay, so the next thing, which is something which is quite new, is only actually covered in the DMZ one at the moment. We have a NFS share called software actually hosted off the SAN, and on there we have an ISOs folder, in there we have a Linux folder, and currently we only have the RHEL server here. What we can do is we can go into a VM, edit, and instead of having to try and mount it through the client and have the ISO loaded up onto your desktop and whatnot, you just upload it onto the share on the SAN, and it's presented read-only to, well, it will be presented read-only to all the VMware hosts. Currently it's only done for the DMZ ones. You go to the CD drive, data ISO store, you go into, we can't do that one because it's not presented, so we have to do the big Jira test. Edit settings, CD drive, data ISO store, browse, software share, ISOs, Linux, RHEL, boom, it's mounted. Then you just hit connect, or connect to power on if you want to boot off it, and that's how you can boot off an ISO image if you want. Most of our stuff is done off network now, but you can do that.
What's the easiest way to get the images onto there?
Just mount it via NFS onto your desktop and upload into the software.
That is what?
It's off the SAN, so it'll be 0.248 or 55.248. But I will have to grant you guys access to it at the moment because this is something which I was setting up the other day and I haven't opened it up for everyone yet. Right. So that's how you mount. And creating storage on a VM, of course, which is always important. We go to add, hard disk. We create a new virtual disk, or if we have an existing one which we copied from another VM or from the backup tape, we can use that. So we create new, we get to choose its size. Thick provisioned lazy zero allocates all the space for the VM, but doesn't actually format it. So it just goes block of space, but I don't know what data is actually stored in there. Eager zeroed obviously goes through and formats it, will take considerably longer, but is recommended if you're going to set up database VMs for SQL Server, MS SQL, or anything else. Thin provisioning only allocates the space you use, and on ESX versions not running the VMware agent and before 5.1, and I think there might be some OS restrictions on it as well, it will not reduce the amount of space used when you delete files. So it will grow but won't condense. On Windows, with the client installed on 5.1, it will reduce that down now. I think there might be some limitations with what that can do with Linux though. We generally don't thin provision because it leads you into a situation where if the LUN runs out of space because people don't monitor it, or we can't order disks quick enough or whatever, you can actually cause a load of VMs to simultaneously crash, and it's generally quite bad practice.
The down effect, the other part of it is to save space for thin provision. So
yes. So thin provisioning is fine if you're going to be working in like cloud environments where there's going to be lots of instances of very similar VMs, and you've got lots of storage nodes and lots of storage groups, and you can move stuff about. So when things start to get full, you can have DRS automatically, move it into a new storage node you bring up. But in our environments, we're not that dynamic. We're not bringing on storage, at the sort of RAID. We've only got 2 different RAID sets. It's not something which is growing dynamically. You can store it with the virtual machine in its current location, or you can actually store the new storage elsewhere. This would automatically choose where to store it because we're using the storage DIS, which we'll get onto later. But pretty much all the time I've ever used it, I've always stored it with the virtual machine. Times you would probably not want to do that is if you've got something which needs to be highly performant and you want to put it onto a special LUN, which is going to be for high IOP throughput, so solid state storage, or 15k spindles rather than 10k, XYZ. So yeah, cancel that and cancel that.
So you don't want it to be. So generally you store it with a virtual machine unless it's performance based.
Yeah, pretty much. Unless you can come up with a good reason why not to. Okay. VMs themselves. Let's have a look. Okay, so at the moment, this VM here is a slightly older VM. It was created when it was on the old cluster. As you can see, it's not currently online. And it's running Ubuntu Linux and VM hardware version 8. Now 5.1 came out and it launched VM hardware version 9, which adds additional features. You need to be using hardware version 9 for thin provisioning to be able to reclaim back the storage, and there's a bunch of other quite cool features which it allows you to use. of which we're probably never going to touch them.
Workstations was telling me last week that it was up to 902. They'd like to update.
Oh, workstation compared to this is different. Yeah. Workstation version 9 is a release which kind of coincided with 5.1 ESX. But yeah, the VM hardware version underneath, it's not the same. So yeah, if we want to upgrade that now, upgrading a hardware version will sometimes, in some cases, because basically you're ripping out a bunch of hardware from the server and putting in some new hardware, which is effectively what you're doing. Sometimes the server won't boot. It'll break because the software isn't designed for the new hardware. So you might want to...
Can you snapshot it before you do it and go back, or is that
you
not possible?
You can't snapshot, because for hardware upgrade change...
Clone it then.
Yeah, if you want to take a backup beforehand, you clone it, then you give a hardware update, you bring the VM up, if it's all working and operational, then you remove the clone. So to clone, we go clone, we choose the machine name, we put it in Chiswick, we'll put it on the IT cluster, put it in test build server, and we'll let it choose where it puts the space. Do you want me to actually clone it, or are you happy with the fact that's going to clone it?
That's fine. And when you clone, is there a preference to having to shut down the machine before you clone it, or does it depend on the IO level or something?
If you clone a running machine, it will take a snapshot, and then it will clone the snapshot. If you clone an offline machine, it will clone the offline machine. So any changes you make to the machine after you've started the cloning process won't get connected across, or shouldn't get. It could do a catch-up snapshot afterwards. But yeah, you can clone online machines absolutely fine. Obviously you have to be aware that if you do lots of I/O activity, you might start affecting the performance of other things on the cluster. So just keep that in mind when you're doing lots of I/O. So if we want to upgrade virtual machine hardware, we click here. It's pretty simple, really. Any questions about it? Excellent. Let's actually do it on that host because it's not important, so I don't need to take a backup beforehand. Power on. I'm not in a sore throat, too much talking.
It's a dry.
Just
There we go.
see, it's worked because it's
It's worked because it's a Bunty version 1204.
Carries some energy to deploy this to
Right. So if we're going to shut this down, no, okay. Have you all installed VMware tools before? You know how to do it?
Mm-hmm.
Excellent. I won't bother going through that then. Control B.
I've never done it on Linux.
Haven't you? Would you like me to show you how?
Yeah.
Shit. Sorry. I'm glad to show you how to do stuff. Right. So
Do you pop the CD into the virtual machine, browse to the disk, and then run the installer package?
Pretty much. I'll show you
Okay,
how.
well, we consider it done.
Oh, okay. You have to untar it and stuff and use a couple of flags.
Why would they do that? Why would you have to untar it? What is the bloody Linux world obsession with tarring crap up? Why can they not just give you the file? Why does everything have to be tarred? Are you listening to me?
I don't understand why they use tar.gz. I mean, I know tar and gzipping are separate, but they're used so commonly together. Why couldn't you just do a tgz?
well, you can.
Well, I know you can call it whatever you like, but it doesn't make sense to call it tgz.
Why not just have it in a compressed executable? It just makes no sense.
You can do that as well.
But they never do. It's always untar.
But the VMware installer.
Georg is being anti-Linux. We need a dose of a rash.
The only thing you get with a rash is a rash.
Okay, so we're going
That
to
pretty
shut
much
down that
scuppers your
machine.
chance of using this to present it to the rest of the team.
Recommended start.
bleep, 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 bleep. Bleep, 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 bleep.
We've been going 40 minutes, don't lose your momentum.
Yep, I'm trying to get through it. I really am. I've got through 3 out of 7. No, 3. No, I've done 2 out of 7 sections. No, 2 out of 6.
What?
Yeah, hopefully it'll be a bit quicker now. Okay, memory. We have 2 gig of memory in the host. We have 1 CPU. Now, generally what we want to be doing with machines is allocating them as few CPU cores as possible and allocating them no more and no less than 4 gig of RAM.
Because with 4 gig you can expand it later, and less than 4 you can't.
Bingo. Well, you can, but you have to turn it off to expand it.
Yeah, I know. So I listen.
Yeah, Ubuntu, you can't actually dynamically expand it anyway, so if you're doing Ubuntu, it really doesn't fucking matter. But if you're using Red Hat or Windows, you can dynamically expand it.
I still haven't got a definitive answer.
Hold on. Let me just get through this. So, in the options menu, there is a memory CPU hot plug. To be able to add memory dynamically, that needs to be enabled. You can only change that flag when the machine's off. Well, you might be able to change it when it's on, but it won't take effect until you reboot. So it's kind of important, if you think you might need to add more memory in the future, to make sure that that is set. Okay.
Where is it? Okay.
Resources, Advanced Memory CPU Hot Plug. The other useful thing is boot options, I believe. Yes. Power on boot delay. If you want to do anything like network booting or anything like that, setting the power on boot delay to 5000 is really useful because it gives you a few seconds, or 5 seconds exactly, gap where you can actually get yourself into the console and ready to hit one of the F keys before it just flicks past it really quickly. So F12 is network boot, for example. Now, in resources, you are able to reserve memory. Okay? Now, this means there's a chunk of memory or a chunk of CPU which you can reserve for that particular VM. Now, what VMware can do is something called memory ballooning. So if VMs are using memory blocks which are identical, so if you've got 1,000 Windows machines which all use exactly the same memory and waste it all and never use it, it will set up a ballooning instance in effect, where instead of having to have that same 100 meg of RAM cloned 1,000 times, it will just have one copy of it and all the VMs referencing it.
A memory shared between machines?
Yeah, if it's identical and its hash of the memory is the same, then it condenses it. That's called memory
ballooning. How common
ballooning.
is that though? I mean, machines just have to be in perfect sync.
Well, that's the thing. I mean, it doesn't just look at like a 100 meg chunk. It'll look at lots of tiny little sort of sectors of memory, and it'll just compress them all down.
But it compresses the memory down to exactly what's needed anyway. So, are you saying it's effectively a memory dedupe?
Yeah, in effect, deduping memory. You never, ever want to run out of memory on a VMware host. You never even want to get close. If you get above 75% usage on a host, well, to be honest, let's say 65 for the case of this, you want to be looking at either putting more nodes into cluster, or you want to be looking at putting more memory in the servers, because as soon as it runs out of memory, it will swap out the RAM to actual disk. So the VMs themselves will think they're still accessing fast RAM, but it'll actually be accessing swap. This will give you massive performance hits.
As it would on a normal machine?
Well, no, because a normal machine
is a bit clever about the caching because it knows what it's doing.
Exactly. So a normal machine would say, oh, I'm using 20 gig of RAM, but 6 gig of this is just for buffers and cache. So what I'll do is I will get rid of some buffers and cache and put the active programs into memory. But the actual underlying VM won't know about this this swapping, so it will be trying to cache stuff to memory to make it fast, but it will actually still be on disk. So this is a really, really important thing to make sure you never run out of memory. I cannot emphasize that enough. I'm letting him type it in capitals. I don't know. I think he's texting someone, but he's definitely typing.
Thing that WNK Bank is easily accessible.
Okay, you can also reserve CPU. So again, similar sort of thing, but unless you really, really have to, I'd not recommend reserving CPU or memory in our current cluster. We used to reserve memory because we had much tighter memory constraints. We wanted to make sure that the machines we were running had guaranteed in-memory space. But now that we've got a lot more memory, we're going to have a lot more VMs running on the hosts. It makes more sense to not reserve the memory, but we still need to monitor it closely. Right.
Reserving memory would actually guarantee for the particular host that you want it to be guaranteed for.
Yeah, so it wouldn't swap that memory out ever. It would reserve actual memory for that host.
Which, in theory, if every single host you had that reserved memory, means if someone comes in tries to take, if an alternative host didn't have that set and tries to take more memory, it should either, it would not be able to overcommit memory.
Yeah, you can't over-reserve memory on a host. It wouldn't let you.
Okay. So, but effectively in that scenario, if you have one person who created a host without actually calculating things properly, they would not be able to affect the others because all the others have reserved memory.
Correct. But what they could do is if they started swapping out and their 20 gig of RAM on their new VM, which they're hammering, is all accessing from disk, it's going to kill your I/O. That will then have a knock-on effect either to the underlying host if it's local storage, or to the VMs if it's SAN storage. So it is important to know what's going on in your environment and kind of have a set process and a set way of building things. So yeah, we can't just willy-nilly spin things up. One of the biggest problems with virtual environments is people just think, oh, it's virtual now, we can just spin up as many servers as we want. And the problem is you start doing that, and then if you haven't calculated the resource usage and utilization, it's going to come back and bite you in the ass, because when your whole farm grinds to a halt, you're going to start debugging yourself through 800 VMs. It's just a nightmare. So you want to make sure you're doing it right from the get-go.
Currently, at the moment, how many VMs do you have in total number?
What's that one CPU? Do you know what that does?
Hyperthread core sharing.
It's an old set. That's answered my question. I'm just trying to think.
In the name.
Given it's all virtual anyway, I'm just wondering what the benefit is of actually splitting the threads across physical cores.
I haven't dug into this particular feature.
Okay, so
I believe it's going to be a performance related feature.
It'd be some form of arcane performance related thing.
No, because if you think about it, you have in environments, so this server will have core 0, which will be one entrance to a physical core, and then core 1, which will be the second entrance to the same physical core, which will be the hyperthreaded entrance. Yeah? Now either of them can run as fast as each other, but they only actually have one core behind the two of them. I'm kind of guessing this is actually going to present that information through to the VMs. So the VMs are aware if they're actually hitting the same core with two separate CPUs. So it can decide, oh, I'm maxing out this one, there's no point trying to send it to this core because it's actually going to be hitting the same CPU. That makes sense.
That's really badly written. Hang on, what are the options now? In the mode. Sensible. I'm not sure, 100% sure that's what it does, but I can look at that later.
Look it up. If it's different, let me know. But yeah. Oh, you can limit the IOPS. Yay. That's available in the feature actually. That'd be quite useful. There used to be a feature somewhere. Have they removed it? I think they might have removed it. Huh. Okay. You used to be able to set what cores the CPUs used to go through to exactly. You used to be able to map them, but anyway.
That's what I was wondering actually whether you could do that.
Yeah, you used to be able to. They might have moved it. I'll have to have a look into that. This is again how many a number of cores we've got is 1, but you can actually choose how it's presented to the underlying VM. So, for instance, some applications have got licensing issues where they'll allow you to have a single CPU license, but maybe up to 4 cores per CPU, and it will actually annually look at how it's built. So, if you run it on a VM and you've got 8 physical CPUs presented to it, it'll demand 8 licenses. But of course, underlying in the host, we've got 2 physical CPUs and 8 cores per CPU.
Most is like that.
Yeah. So you can turn around here and you can say we've got 2 virtual sockets with 4 cores on each, which will give us a total of 8 cores. Or we can say 1 virtual socket with 8 cores. So it depends how you want to present it to the actual OS. You can change that round, which is mainly for licensing.
So about the socket and the core.
Yeah.
Can you just elaborate more on that again?
A socket is a physical CPU. A core is the number of cores on that CPU.
Okay.
You can virtualize multi-core processors.
And that would equal the actual physical one. When you virtualize,
No, there's no direct.
What's the
mapping
proportional? What's the percentage? Is there something like that? A percentage or a formula that you could say this equals that much in physical?
Depends on the usage profile.
Well, it depends how many other people are using the same CPUs.
It's really they should rename that to make it more apparent. It's just number of virtual CPUs, number of cores per virtual CPU would make a lot more sense.
Well, sockets makes more, because the thing is with vCPUs, it's kind of a term which is people throwing around, oh yeah, I can add you another few vCPUs onto there. They don't actually mean virtual sort of CPUs, they're just talking about processing cores. Whereas a socket is very specific.
Virtual cores on there.
Isn't it effectively
Well,
just a
socket
process?
is very specific. A socket is a physical socket.
So the socket here is a location in the physical layer.
No,
No.
this is
It's
all
still
virtual.
Yeah, I'm just trying to understand the mapping between that and the.
There is
There's no direct mapping.
It's how it's presented to the guest OS.
Exactly. What he said.
What he actually was complaining about a minute ago was the fact he couldn't find the option to actually specify what physical cores went to which virtual server.
Yeah, it used to be in resources. I'm sure there was like advanced CPU. Well, advanced CPU, but it's not here anymore. Oh well, sad face. In fact, just before we move on, let me just check. In Romania, let's say they're running. Oh no, it's 5.1. So we've got 5.0. Here we do. Let me just have a look in an older one. There. So they've removed it in 5.1. But yeah, you used to be able to actually choose exactly what cores you were using.
To be fair, it's vanishing through instances without a meaning.
Maybe it's because it's in a cluster that you can't do that. That would make a lot more sense. But that's 5.0 as well. That's 5.1. Let me just check on one of these VMs. Edit settings, resources. Yes. Okay, so it's because it's in a cluster, and you can't do the hard mappings in a cluster because when it vMotion stuff, it is going to then cyclode in areas where, yeah, okay, that's absolutely fine. That makes a lot more sense. So that's vCPU standards, VRAM standards, networking on a VM. Right, so networking on a VM. If it's on a distributed switch, it will end in the end of the name of the distributed switch in brackets. If it's not on a distributed switch, it won't have that at the end. I can't show you something not on a distributed switch at the moment because there's nothing which exists on VMO5 for me to be able to show you. But yeah, rest assured that basically all the networks will be named roughly the same because that's what I called them, but it won't have DB switch at the end of it. What we want to be doing, you can see there's a port number here. You're only going to ever need that if you're going into some advanced debugging, so yeah. The networks, we basically want to be building the new dev VMs are going to be going into a new dev network, which is VLAN 70. New servers we're building, we're putting in VLAN 65, which is our new internal server VLAN. And I'm trying to build everything in VLAN 65 as dual stack as well, so just keep that in mind. It'd be good if we can do the same in all the new sectors. So basically try and avoid using the old internal VLAN 20 because it's going to go away soon. VM tools. VMware tools, very, very, very important. You need to have them on all VMs running on a cluster. It allows loads of advanced features and core monitoring stuff and other bits and bobs. The most important thing is to do with performance. If you've got some VMs running VMware tools and other VMs not, there's actually a negative performance impact. You'd be better off not running VM tools on any VM, because at least then it knows where it stands. But you want to run VMware tools because it will give you a performance increase and a balancing increase, and it will monitor IOPS in a much more granular way. It will monitor what processor you're using, what CPUs, so it should help prevent something called CPU hopping, which is something you get when a single-threaded process sometimes hammers a CPU. It'll actually jump the virtual CPU between physicals. Each time it does that, it actually adds latency into the processing, and it slows down your actual grinding. So yeah, having VM tools on your machines is very, 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 very important. And I will always shout at you if I find out you're building VMs without VMware tools. But it's important not to forget. If you think you may have forgotten, you may go to the cluster, IT for instance, open virtual machines, sort by powered on, or the state. There we go. We'll mark over here, and we'll scoot across. Right click. VMware tools running status, and VMware tools running version. You can see the machines which are off are reporting a mixture of not installed and out of date. When we bring them up, they'll have to be updated, but as they may never come back up, I've left them for the time being. All the VMs down here, as you can see, the VMware vCenter doesn't have tools in the conventional sense, but there is a third-party set of tools on there which it can recognise. But all the VMs on here are tickety-boo. I think you'll find that the Dura Test VM, which I spun up just the other day, probably doesn't have tools on it. Yes, not installed, exclamation mark. In this particular case, because it's the only VM on the cluster, it's not a problem. We're going to delete it in a few days, so I'm not massively concerned. But if for whatever reason we decide we need to keep it for longer and we're putting other VMs on, I'm going to have to install VMware tools. It also means that there's potential performance increases we can get by putting VMware tools on there. Right. VMware tools. Can I labour that point anymore?
I think you've labelled it now.
Excellent. VMware tools, very important. Write it down. DRS. Now this is when we start moving into the cool shift. DRS, my friends. Okay, so basically, here is a recommendation made by DRS telling us to power off VMO5 because it's not needed. We don't need VMO5 at the moment. We're not using enough resources to warrant it being online. I've actually manually overridden DRS for the moment because I needed the VMs up while I'm doing some analysis for the SAN upgrade. So I've manually overridden. Usually, it would automatically shut down the ones it doesn't need. You can actually have a look at the history here of what it's done, and the history doesn't go back very far, which is fantastic. In fact, it looks like it's moved a VM only a few minutes ago onto VMO5. Fantastic. So there is an example of DRS actually working. Now, if we jump back into recommendations and go to edit, you can also set up power management here. As you can see, I switched it to manual. I'll be putting that back to automatic as soon as I've finished pulling off the stuff I need. Cluster features, we've got DRS turned on, we haven't turned on HA for now. DRS is in fully automated mode. It's not too aggressive, it's not too conservative, so it's not just going to bounce stuff around for the sake of it, but at the same point it's going to move stuff when it needs to be.
What's DRS again?
What's it stand for?
Distributed resource.
Something or other. Yeah. It basically monitors your CPU and memory, and when a host starts to get a bit hot, it'll move VMs onto another host which is less hot.
Right.
So it's basically resource usage balancing. And when our cluster becomes quiet at night, the idea is it'll shut down all the unnecessary hosts. We have some rules here. So let's just have a look at this one because I think this is one we're going to be most familiar with. So we've got WASM, new, and WESM. Okay? So WASM and WESM, basically the virtual ones. We're saying here we want it to separate the virtual machines. So VMware will make sure that WASM and WESM are always kept on separate physical nodes. So in case one goes down, we don't lose them both. Yeah?
So presumably, if you had one extra box in there, it would never power off VMware 5. So it couldn't come back this kind of
Yes. Yeah. So at the moment we could run off a single host easily, but we've always got two on in the IT cluster because of the DRS rules. Okay.
Now look again at how you set it up. Okay.
What's the lag to bring one of the hosts up?
It's about 10 minutes.
Okay, so it's preset yours. The types are preset. Okay.
Yeah.
Okay. Alright. And you decide on which hosts and then okay. You just add. Okay. I thought it was a bit more sophisticated than that.
No, it's really not. Right. So, it's VMware brings the host up and down based on using its ILO. So it'll shut it down and then bring it back up with the ILO. So if I go into VMO5, go down to power management, you can see it's got a login, the IP address and MAC address to the ILO. Connect to it, bring it back up, do whatever it needs to do. How's it do it? Yeah.
Does it say the password in there?
The password is in there, yeah. Hosts, power, hosts, VMs and DRS. So that's how it does the power. The VMs, that's virtual machines. On VMO5 we've got this one. On VMO6 virtual machines we've got all these. And on VMO7 we've got these. Now what we might want to do actually, just as an example, because it's something we need to do anyway. 232 and 233 are DCO5 and DCO6, aren't they?
Yeah.
Okay, so let's go in and edit this rule, because currently we're separating 5 and 7, which probably aren't as important as 5 and 6 are. Let's remove that. Yeah, and then let's add in VCO6. Boom. Let's add that. Okay. Now this only runs every minute or every few minutes. We can manually run it here if we want to. We manually run it.